An equally interesting question might be how we figure out what is the first word that comes to mind. For example, what's the first word starting with an A? Many of you might say apple. Are some words more important than others? Is it just the common words which are more important than others? In this context, if you're talking about this course and this lecture, what's the first word that comes to mind starting with G? I'd bet many of you think Google. Does this have anything to do with how Google figures out which topics to include in the top 10 documents it displays matching the query Clinton plays India cards? Importance of search results in Google, as many of you may have read, is because of an algorithm called PageRank, which we'll describe in a minute. But we also want to ask, is there anything deeper, which we'll come to just after that. So let's look at PageRank. The web consists of documents which are linked to each other through hyperlinks, and this was the initial structure of the web when it first became very popular in the late 90s, and it remains so today, but we'll come to that shortly as to how it might be changing. So what Brin and Page at Google, the founders of Google, imagined while they were still at Stanford was, suppose there's a random surfer who hops from page to page, hyperlink to hyperlink at random. So at a page, the surfer chooses at random any of the links that go out from that page. So the surfer is going from page to page, and the question that Sergey Brin and Larry Page asked was, what is the relative probability of visiting a particular page? So of all the pages on the web, which pages are more likely to be visited by such a random surfer than others? And that probability across all the pages on the web is the page rank of that page. Now, it might appear that the number of hyperlinks going into a page is sufficient to compute its page rank. Obviously, if more links point to a page, more likely it is that this random surfer will reach there. Question is this enough? It turns out that this is not enough. And the answer is no, because even if a page doesn't have many incoming links, a surfer can revisit a page because of cycles in the graph, so that the surfer will go and come back to the page through a variety of different routes, maybe traversing the same link again and again. But because there are so many cycles which return back to the same page, a particular page can become important even if it doesn't have a lot of incoming hyperlinks. The point is that PageRank is a global property of this web graph and cannot be computed simply by looking at the number of links of each page. This is the second major computation that a search engine like Google has to do, computing the page rank of each page. The first, of course, being indexing the web as it grows. This page rank of each page is computed iteratively, continuously, and in parallel on, as we shall see, thousands and thousands of servers. For those of you who are slightly more mathematically minded, the page rank is related to the eigenvector of a particular adjacency matrix. But we're not going to go into that math in this course.